5, last part of combinations here. Now we're going to talk about at least and at most. So that means that you have a couple options. So if there's two different options that meet your requirements, because when you say at least or at most, that means that a couple things work, right? So what do you think you do with those? Like just before we get to the notes, what do you think you do? Yeah, so if I said at least, this one, if I said at least 4 females, if I was choosing females. Right, so we want things above 4, so that means, let's say it could be 4, 5, and 6. So what would you do with the options of 4, 5, and 6? Add them. Right, you're looking at your possibilities for 4, your possibilities for 5, possibilities for 6, and then you add them. That's your total possibilities for having females over 4, at most 4, okay? So you got to get kind of on the right track. So student council decides the 4 subcommittee again, so 5 council members to look at how funds are raised. Again, same story we heard last time. There are 11 total student council members, 5 and 6. How many different ways can this subcommittee consist of exactly 3 females? So exactly is not an at least. Okay, so exactly is simply, that means we're choosing from 6 females, we're choosing 3. And then when the males have to be, if we want, we're going for 5, that means the males has to be 2. So 5 choose 2.
Why do we have to include the males?
Because we're still finishing the committee. We want the total committee for 5. So then that would be simply 200 options. 200 ways you can form the committee with exactly 3 females. So now this is the new stuff today, or this lesson. At least 3 females. So now we have to do 6C3, 5C2, 6C4, 5C1, and then 6 choose 5. These are all the 3 ways that you can choose at least 3 females. Yeah, it's a 4. Yep. Sorry, I'll rewrite it here. Just I wrote a 5. Yep, and then we'll add these totals. So 6C4. A couple things to pay attention to. We know the subcommittee consists of 5 people, right, Andy? Okay. Okay, so then we have 3 plus 2, 4 plus 1, and we have the 5. So all those are always at the 5 because our combination is 5. Okay, so then we have simply 200. We already know this one. We found that one out. Then we have 15 times 5, so that's 75. And then 6 choose 5 is 6. And we add all those up. The total is 281. There's 281s to have at least 3 females. Okay? At least 1 female. So at least 1 female, we can just steal the 281 here, and then we have to do it for 2 and 1. Okay? So we have to do 6C2. 5C3, 6C1, 5C4. I gotta get those 2 totals, which is, this one is, the first one, it's 30 and 150, and then I add 281 to that. What's that? Mm-hmm. Yeah, 6C5 is the max. That's all over here. So we stole the answer from the right. We don't have to do those again. 281. We know from 3 and up is 281. So we just add the 1 and the 2. Okay, so that's 180 plus 281, so 361. So it's 361 to have at least 1 female. Okay, or wait, was it 461? Oh, sorry, 461. Didn't carry the 1. 461. Okay. Okay, what's another way you could do this? Another way you could do at least 1 female? At least 1 female, you could do no restrictions minus all male. Okay, another way you could do this is you can do, for at least 1 female, you can do no restrictions. So no restrictions would be our 11 people just choose 5. Doesn't matter, any 5. okay, and minus if they were all male. So all male would be 11 choose 5 minus 5 choose 5, which gets you 461. It's kind of silly on that one because how many ways are there to choose all males? 1. Yeah. 5 choose 5 is 1 because of the order of the guys doesn't matter. Okay, so 5 choose 5 is just 1. 462. If this is 462 minus 461, or sorry, minus 1.
Minus 5C5, that's you minusing the females?
Nope, that's all males.
Oh, this is all males.
So this is saying this is the other way you can find the answer for C. We already did it one way. This way is what are your total combinations possible, all the combinations possible, subtract out the all male option. Because if it's all males, there isn't a female. What's that? Exactly. So we're taking all minus all male. This is the only time when there's not a female. So we're taking all combinations and subtracting the all male one. That means the rest that's left over is at least one female. This is like the same thing we did earlier. No restrictions. Like we're doing this is another way of thinking about it in terms of subtracting out what you don't want. We don't want all male, right? We don't want all male because we want at least one female. So that means at least one. So we're subtracting if they were all male. The thing, whatever's left over is at least one female and above. And it's simply all male. It's only a one chance. There's only one option to do that. 5 choose 5. Okay? If you like this, just stay with this then.
For any term, it's like, so like 5 choose 5 is the same number.
Right, because there's only one way to choose all of them. Yep. She just asked 5 choose 5, 6 choose 6. Those are always 1, yes. Okay, so example 2 says consider the standard deck fit 2 cards. So we're going back to the cards. How many different 5-card hands can be formed containing at least one red card? So at least one red card. So this is one that if we do at least one, we don't want to do 26 choose 5, 26, or sorry, we don't want to do this. We don't want to go all the way down. 26, 25, 24, that'd be ridiculous, right? So this is where you want to use what I just talked about. Do the stuff you don't want. Okay, so we want to go, what's the no restrictions minus what? 26 choose 5, all black. Do you see what she just said? I want to subtract the option to get all black. So if I get all black, there's not a red. There's a 26 choose 5 is the possibilities for choosing 5 blacks. Is 26 choose 4 a problem? No, because if I choose 4 blacks and I have 1 red, I'm good. Okay, so no restrictions would be your no restrictions would be 52 choose 5. Okay, so when you do that, you're going to get 259,8960, so 2 million, minus 65780. So there is 2533180 ways to get at least one red card. Pretty common. Pretty common to get at least one red card. It's 2.5 million. It's almost that. Okay. Okay, at most 2 kings. That means we want 2 kings or less. Okay, so with this one, we want to think about 0 kings, 1 king, 2 kings. That's the most we can have. So you want a hand with no kings, 1 king, or 2 kings. Okay, so what would the write-up be for 4 kings? Or sorry, no kings. What's that? Nope. Close. Not remember, 0 is a total. So let's just talk about kings. 420 times, what's the left? This is what you just said. 48, choose 5 now. Yeah, because we didn't choose any kings, we have to take 5 cards, right? So here's the thing, when you're doing 5 card hands, guys, these need to add up to 5. Because that's what you're choosing. So we're doing 4 kings, we don't want any. So 48 cards that aren't kings, we want 5 of those. We want 4 kings, we're going to choose 1. We want 48 cards, we choose 4 of those. 1 plus 4 is your 5 card hand. 4 choose 2 kings, 48 choose 3. These are the 3 options for getting 2 or less kings. And what do we do with those? Add, multiply? We add them. Okay, so the first one is 171, 2, 3. Oops, I'm a decimal off here. Not decimal off, but I'm a comma off here, sorry. So it's here. It's 1.7 million. Okay. The second row is 778,320, so 778,000 ways to get 1 king. And then the third one is 103,776. So you can kind of see, chance of getting no kings is pretty common. Chance to get 1 king, decently common. Chance to get 2 gets a little bit smaller. It keeps getting smaller the more kind of specifics you're looking for. So we add these now. When you add all of those, you get 2594, 400. And I want to point something out here. 2594, 400. So 2.5 million. So guys, what's the total for cards again? So what's 52 choose 5? Yeah, 52 choose 5 is 259,860. Those are pretty close, yeah? So this is why. Getting 4 of a kind of kings, hard to do. Not very many ways to do it. Getting 3 of a kind kings, also decently hard. Not a lot of ways to do it. So you're seeing that this compared to these there's a lot of ways to get 2 and less. But the 3 and more is where things get more difficult. That's why it's a stronger hand. Okay? Any questions? All right, let's keep going here. Let's get a couple more examples here. All right, combinations which are equivalent. Fran and Bernie have identical collections of vintage toy vehicles. Fran selects 2 toys from the 10 shown for her display in her cabinet. Since the order of display does not matter to her, she calculates that this can be done with 10C2 or 45 ways. Yeah. Oh, we skip C? What's C say? Oh, exactly 2 pairs? Oh, thank you. Exactly 2 pairs. So let's do C. Sorry, guys. Didn't see that. Okay. So exactly 2 pairs. So to get exactly 2 pairs, 4 choose 2 and 4 choose 2, because to get a pair, it's 4 of a card. We need 2 of them, and we need 2 of those. Okay. And so then we want 44, choose 1 for the last part. Okay. All right, so the other thing we have to think about is that we got 4, 4, okay, and then it's the so we have 13 choose 2, which stands for the 2 values for the pairs. So what this is a little bit confusing. But this stands for the 2 values, the 2 cards you pick, yes. Because here it is, we want 4, we select 4 of 2. So let's say 4 2s, we check 2 of them. 4 jacks, we select 2 of them. We also have to identify the combinations to pick those pairs. There's 13 different type of cards. We want 2 different to get 2 pairs. So this right here is standing for the 13 types of cards. We need to pick 2 to identify what our pair is going to be. So these, I wish they would have wrote these together, but these things are connected. This guy is the leftover card. Okay? So it's kind of like your options for picking what pairs. That's what 13 choose 2 is. So think about it this way. There's 13 types of cards. I need to pick 2 types to have 2 types of pairs. Yeah, it's hard to remember that. Yeah. Because what are these, right? Yeah, what are these? Right, and since you just identified the 2, that comes from here. How did you get the 2? There's 13 cards to choose from to pick a 2. Yeah. Yep, Aiden.
Why do you have the 4C or choose 2 twice?
Because remember, these are the cards that make up your hand. This is how you decide which pairs to pick. So it's 2 pairs, so you need to have king, king, 4, 4, and then an 8. Right. So listen. Yeah. So to what Cash is saying, to make you close this loop on this, because this is the most confusing part, and people forget this all the time. If I tell you how many different ways can I get 2 2s, 2 jacks, and a whatever card, you only need this. But since we're not telling you what pairs you want, you have to account for all the different types of pairs we could choose. Okay? So that total comes out to be 1, 2, 3, 5, 5, 2. So 123,552. Okay, thanks. Good thing we went back to that. That was an important one to go over. Okay, so now back to the toy collections here. So Fran selects 2 toys from the 10 shown for display in her cabinet. Order display does not matter. She calculates this to be done as 10C2 or 45 ways. So example, she just says, I'm going to pick these 2. Okay? And so the order doesn't matter that she displays them, so she doesn't care. She just picks those 2 for the cabinet. Those 2 are in the cabinet. Okay, Bernie selects 8 toys from 10 shown for display in his cabinet. Since the order of display does not matter to him, he calculates that this can be done 10C8 or 45 ways. Explain why 10C2 is equal to 10A2. Why are these the same thing? Yeah, 10C8, thanks. 10C2 equivalent to 10C8. Good. So Cash kind of said it. The reason they're mirrored is because you could also think about it as Fran, by picking 2, she's picking of 8 different ways to leave them out. Bernie is thinking of 8 different ways to put them in. So there's still 8. That symmetry is coming from what you pick to go in. There's also that combination out. So the 10, choose 2 from 10 and turns 8 from 10 is the same idea, because that 2 and 8 just switch positions, but those combinations are the same. So it's the fact that it's 10 and 2 and 10 and 8. So like, for example, would 10 and 6 and 10 and 4 be the same? Yeah, they should be, right? Okay, so because they say in words, because essentially Fran, by selecting 2, has 8 left out, which is similar to Bernie putting 8 in. Okay, so in terms of the factorial notation, we'll look at the math with it in a second. So again, because Fran has left out 8, brought the 8 there, left out 8, it's similar to Bernie putting 8 in. So in terms of the factorial notation, we use the formula that we just learned for NCR. 10C2 is 10 factorial over 8 factorial 2 factorial. 10C8 is 10 factorial over 2 factorial 8 factorial. Do you guys see it? They're the same thing. because of multiplication, right? The 8 times 2 and the 2 times 8 factorial are the same thing. So let's give another two examples of equivalent ones. We said 10C6 and 10C4, right? That would be one example. Another one we could do is they did 12C3 in the notes here and 12C what? 9. Good. Okay. Good. So above examples represents this. So NCR equals NCN minus R. So just the flip side. Okay. All right, so they're just going to show you a little proof here. I'll show it to you. For D. It's going to be ugly because there's going to be a lot of letters, so don't freak out. All right, so NCR equals n factorial n minus r factorial r factorial. We'll leave that there. And then we're going to do the NCN minus r. That's n factorial okay, so I just put it in the form. It's weird, but our r for the second one is n minus r. So now I'm just going to simplify. What's this simplify to? What's that? Yeah. N minus n, right? This is an r. Bracket. Okay, so it's n minus n, right? So the n's cancel. What's minus minus r? R. Just the proof. This is the same thing. What's that quick? You're just simplifying your like terms. Okay. All right, solving for n in combination problems. So during a Pee Wee hockey tryout, all players met on the ice after the last practice and shook hands with each other. Algebraically determine the number of players who attended the tryouts if there were 300 handshakes in all. Try to figure out how many people there was if there's 300 handshakes. Okay, so you're working backwards. So that means that we know that we don't know the number of hockey players. We know that it takes 2 people to make a handshake, and there's 300 handshakes. So that's what we're solving for. NC2 equals 300. So we want to set this up. Right? Oh, I shouldn't have, yeah. That'd be crazy. Okay, so what do we do here to solve? We're solving for n. So pay attention, we're solving for n. What do we want to do? Yeah, I would actually just multiply the 2 first. Let's leave the n's together. So multiply 2. It's 2 factorial, which is just 2. Okay, that cancels here, here. So you have n factorial, and we did this part in our notes the other day. How do we get those to simplify? Well, we know n factorial is, remember, n times n minus 1 times n minus 2 factorial. And so now we can cancel the n minus 2's, right? It's that idea that, remember, your factorials are always n minus 1, and you can keep going down as long as you want. So this cancels here. Okay? And so now what's left is that on top. Okay, look in your notes. We did that in lesson 2 and 3 for permutations. Your n factorials just go n minus 1, n minus 2, n minus 3 as long as you need to go. The last one you have is going to be the factorial now. Because if I tell you you have, if I have 6 factorial, right? 6 factorial is the same thing as 6 times 5 factorial, remember? 6 times 5 times 4 factorial. And so it's that idea. Okay, and so then this is going to be n squared minus n minus 600 is 0. And so then we're going to factor that, which is 25 times 24. So your answers are 25 and negative 24, but we can't have a negative n. So 25. 24 is rejected. Yep, that one is a little more work. That's a good full understanding problem. So 25 players were at the practice to have 300 handshakes. That's what you just figured out. 25 hockey players were at the practice to have 300 handshakes. Okay, last page. Okay. Polygons and diagonals. Consider circles with 5 points marked on the circumference. How many triangles can be formed using these 5 points? Write the answer in combination notation. So why is this a combination first? Right, doesn't matter which one's a diagonal. Like it's diagonal to diagonal. Okay, good? So how would you write A in combination form? How many points are needed for a triangle? 3. So it's 5, C3. 10. 10 different triangles. 10 different triangles you can do. Yeah, that's the point. We don't want to do that. Okay, how about for 2 points? Just doing 2 points, making a line. 5 choose 2. So 5 choose 2, also 10. Interesting. We should know that though, right? It's the mirror. 2 from 5, 2 from choosing 5.
It's
Only 10. Yeah. Good job. Okay. They're not. Okay, so sketch a regular polygon. So just want you to sketch a regular polygon. I don't know what they're doing here with this one, but they're just doing a regular. Do you guys remember, let's say with me, do you remember what regular means when it comes about polygons? Mine's not very good, but all the sides are equal. Yeah, all the angles are the same.
To each other.
Regular, yeah, you should know regular. Yeah, that's a pentagon. That's right. 5 sides. So a regular pentagon, 5 sides, pentagon. 6. Okay, so then there's your regular polygon. It says, from that, how many lines can be drawn connecting 2 points on the pentagon, including the sides of the pentagon? Yeah. Pentagon's 5 sides. So how many lines can be drawn connecting 2 points on the pentagon, including the sides of the pentagon? Okay, so the points are on the outside. So it's still going to be your 5 choose 2, because there's 5 sides. How many of these lines are diagonals? So how many of them go straight across? That's half of them, because the other half is going to be going along the pentagon. So this would be 5. Okay, lines in minus number of sides. So we have our lines in, which is 10, our number of sides, which is 5, because we won't count those sides we recreate. So 10 minus 5 is 5. Now we do the same thing for the octagon. How many diagonals are in the regular octagon? 8C2 minus, 8C2 minus, what do we do? This is lines in, 5C2. Okay, what is that? Someone do that for me? What's 8C2 minus 8? It's 8? 20? Okay? So the formula I just got you guys to get was, it's essentially the sides choose 2. So for diagonals would be NC2 minus N. NC2, so you choose 2 points to make a line. Okay, the N stands for number of sides. Those can change. Depends what kind of polygon we have. Okay. All right, last one. Might want to review this part here. Polygon has 65 diagonals. Algebraically determine how many sides it has. So we're solving for n. So this is 65 equals nc, what? 2 minus n. Oh, guess and check. Good luck with that, yeah. Okay, 65 n factorial, or n minus 2 factorial, 2 factorial minus the n. So again, we're going to draw the n factorial out. So I'm coming up here. N times n minus 1 times n minus 2 to get those n minus 2s to cancel. So now that's where we're at. Not yet, because there's a minus n on the end. So we can't times it yet. We will. Okay, so this is where we're at. And then like Travis just said, so what we're going to do is we're going to times everything by 2. So that n on the right gets hit as well. Don't forget that. That's a common mistake. You're timing everything by 2. So 130, 2n. And now we're to the factoring part. Get everything on one side. So this is n squared minus n. So it's n squared minus 3n, because a negative n and negative 2n, minus the 130. And now we factor, which is n minus 13, n plus 10. We don't want the plus 10, so how many sides is it? 13 sides. 13 sides get you 65 diagonals. Okay, we'll stop there.